Okay, so we're missing Adeline today. We hope she's doing well. We missed Sydney yesterday. She had a visit. Did it go well? Did you eat the food? Did you like the food? Oh, wow. Okay. So you're going to be there for 4 years. You want to like the food you eat, right? Did you stay over? Did you sleep in a dorm? You're not going to be sleeping in a hotel there. That actually would be kind of cool. Just don't do any room and board. Just pay for a hotel the whole time while you're there. Go home, sit in the jacuzzi. What's your tuition each year? $80,000. Wow, you must go to a really good school. No, I just pay for a hotel the whole time. That'd make a good movie. You know. All right. Well, somebody doing college their own way, you know. They pick the cheapest school educationally go to, and then they're like room and board ends up being at a hotel. You know what I mean? So, you know, they just try a different way of doing things. Okay. All right, front page. Here you go. All right, so let's just suppose that was your function. Let's talk about the steps that you took to graph these things. When you're graphing these, what's the first thing that you did? Figured out the amplitude. And once you got the amplitude, you marked the max and the min, right? After we did the amplitude, what's that? Oh. That's how we graph it. No, then for number 2, we did the P. We did the period. That's the second thing we did. So like for this one, the amplitude was 3. The period was 2/3 in this problem. So the period, after we found the period, we divided it into 4 parts. Why 4? Because we have 4 quadrants. And sine and cosine take on their positive and negative values over the 4 quadrants. It takes them 4 quadrants to make their cycle. What's the third thing that you did? You know, to try to graph it, what did you think through? Okay. Yeah, so you looked whether it was sine or cosine. You needed a starting point. See, you know, you're trying to think of how you did it, and that's kind of what teaching is. You try to think, well, how did the students do that, or how did I do that when I was trying it? So for sine, where did you start? You started at 0. I'm going to call it the middle. We started at the middle because today you're not going to start at 0. For cosine, you started either at the maximum or the minimum. And then you're right, Alexa, if the value is negative, sine started going down. If sine was positive, then it would start going up. If cosine was positive, you started at the max, and if it was negative, you started at the min. And that's how we did it. Okay, that's what we did. Those were for A and B values yesterday. Today, we are going to look at, today we're going to look at C and D values. Okay, so here we are. For your notes, we are so see this trigonometric graphs piece? You have sine and cosine right here. Maybe you drew your x and y axis in so you can see it better. We're going to finish off this part right here. So that just means for you when you go to the test, this is what you want to make sure you focus on. Okay, so that's this part. The amplitude is simply the absolute value of A. That does not change. The period is 2 pi over B. Where does 2 pi come from? Complete distance around the unit circle. We divide it by B in case there's a horizontal compression. Okay, that's what you do when you get a horizontal compression. You divide. What do you think is the vertical shift? Think it's C or D? Why? Because it's on the outside. Very good. For example, if you had x to the third and x to the third plus 5, you would say, well, that shifted up 5 units. That's on the outside. Whereas if you had x plus 5 to the third, you would say, oh, that shifted back 5 units. It's horizontal because it's on the inside. So as you said, Holly, it's on the outside, so D will be our vertical shift. Now, if you remember, I told you that for horizontal stuff, don't just simply look at the number. I told you to look at, or to solve the inside equal to what number? 0. So take your inside, which is bx minus c, set it equal to 0, and solve for x. Whatever you get for x, that's your horizontal shift. So take the inside, set it equal to 0. So same rules apply. Remember first semester where we talked about all our different shifts and transformations? We put numbers in front and back on the inside. Ms. Nelson had you guys doing it last year. Well, it comes in very handy when we're doing this. You're going to see how efficient and effective you'll be at graphing sine and cosine functions. Now, don't start with the amplitude. Start with the vertical shift. Then do the amplitude, period, and horizontal shift. So I write them right here. Vertical shift, amplitude, period, horizontal shift. That's the order. That's the way that students seem to have the most success. That's how I will teach you. If you come up with a different way, good for you. Vertical shift. Let's look at the first graph. Do you see a vertical shift? Nope. So say the vertical shift is 0. And what I'm going to do is draw axis through vertical shift. So right now it happens to be 0, which is the x-axis. But later on when it's not the x-axis, it'll be helpful to see something. What's the amplitude? 1. So from the shift, I go up 1 and down 1. So what's my maximum value? And my my minimum value is -1. So I mark the max and min. Then the period, I take 2 pi and divide it by b. What's the b value here? 1. So the period is just 2 pi. Take that and divide into 4 parts. So 2 pi divided by 2 is pi. Divided by 2 is pi over 2. So I have 1 pi over 2, 2 pi over 2, 3 pi over 2. So I just count. Just count. Stop. Before you actually do the horizontal shift, sketch a rough graph right now. Okay? Do it as a dashed line. I used to not teach this step, and about 1/3 of the kids would get it, about 2/3 would not. But it seems since I teach this step, everybody now gets it. So that's what we do. If you want to ditch it someday, go ahead. Free country, your choice. There is a horizontal shift here, but I'm going to ignore it right now. I'm going to just do a brief sketch of this graph as though there is no horizontal shift. Where will I start for this graph? Yep. Start right in that middle. Will I move up or down? Up. Everyone okay with that? All right, to figure out the horizontal shift, what do I do? Set equals 0. X minus pi over 4. I take the inside. I set equal to 0. Add pi over 4 to both sides. You get x is pi over 4. So pi over 4 is my horizontal shift. How does pi over 4 compare to your tick mark? It's half the tick mark. If pi over 2 is 1 tick mark, pi over 4 is going to be right in the middle. So what I do then is my actual graph will be in red right here. I take each of these points and I move them half of a tick mark. And then I can just connect my dots. And then look at how pretty that looks. It's very evident now that I shifted it pi over 4 units that way, isn't it? And that's what I get from a lot of students before. They're like, I think I did it, but I'm not really sure I did it. They could understand the vertical part, and they could understand the amplitude and period, but the horizontal shift was complicated. And so I said, well, let's draw both, before and after. And that seems to really help convince people that they did it correctly. Okay. So there you go. All right. Let's try a couple more, and then we're going to graph them with our calculator. So if you have a calculator, make sure you have that out and ready to go. First one, vertical shift. What is it? 2. And the amplitude is 3. So if the vertical shift is up 2, and the amplitude is 3, what's the highest spot that I'll go to? 5. So that helps me kind of decide, how big I should make my tick marks for my graph. So I got 1, 2. That's my axis. That's kind of the rotational point. 3, 4, 5. So 5 is my maximum. What's my minimum going to be? 3 units down from 2 at -1. What's the period? 2 pi. Do it just like before. And I want to make my graph look really pretty this time, because I'm ready to try something a little bit more difficult. If I wanted to show points on this side, what would be this first spot right there? What? Negative pi over 2. The next spot would be negative pi. You don't have to do this. I just want to show you how you can continue to move along. See, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. If you want to add another mark, go ahead. Now I've kind of filled up my whole viewing window. It's kind of nice. Okay, so I've done the period, the amplitude, the vertical shift. Now is when I would draw a rough sketch. But is there a horizontal shift here? There's no horizontal shift, because some people would take x plus 2 and set it equal to 0. But the plus 2, that's your vertical shift. The only thing on the inside is that x, and if you set x equal to 0, you get 0. So your horizontal shift is nothing. So I don't need to draw a rough sketch. I could just draw the graph at this point because there's no horizontal shift. Where is my graph going to start at? All the way at the top, because it's cosine. Now, instead of going all the way down to 0, it's only going to go down to 2. And then instead of going down to -5, it will go down to -1. And now we've kind of laid out the pattern for how this is going to go. And because I put a couple more tick marks in here, I'm going to add them. And I'm going to kind of go the other way over here. So now I've got more than one period. You know, looks like I've got just about 2 periods here. Draw some really nice looking graphs. Okay. All right. Take out your calculator. Let's see if we can graph that and make it look just the same. Oh, koala bear. Who changed that to a koala bear? Was it one of you guys? No? No? So we're going to practice graphing these on our calculator. That way you can check to see if you did them correctly, if you do not have it in the back of the book. So where I start by graphing these is I go to my window. So this is my window right here. What's the smallest x value that you have on your graph? -pi, huh? So -pi is my smallest x value. It's all the way to that side. And then my biggest one, it looks like I've got a 5 pi over 2. So I can just write down 5 second pi divided by 2. And your calculator just changes those to decimals. Okay. Your x scale. What's each tick mark here? Each tick mark is a pi over 2. So I go second pi divided by 2. It looks like the biggest y value is 5, and if I put it down here, then the smallest y value would be -5. It looks like I put a tick mark every one. So I've kind of made my window. Now, if you go into y equals and actually punch that function in, 3 cosine of x plus 2. And there's one last step. You think I'm working in degrees or radians? Radians. So if you go to mode, make sure that your calculator is placed on radians. I felt bad that your test, some of you guys ended up, your results were wrong for your triangles because you're working in radians instead of degrees. So if you're solving triangles, you're working in degrees. Stuff like this, you're working in radians. Some people borrowed people's calculators for the test, and you got to check to make sure that you're switched over properly. So I'm right there. I plug that in. I like to have this be bold. I press graph, and we'll see how much it matches what I drew. What do you think? If you got an error, well, probably your window's messed up. So I went -pi, went 5 pi over 2. I went x scale pi over 2, x min of -5, max +5, scale of 1. You type in your y equals correctly. You have a plot up here. Is it on? Take it off. Rule number 1, make sure your plots are off. If they're on, you might have a conflict with your window. Yeah, plots are on. They're probably on from Algebra 2 last year. Yeah, you never turned them off. There you go. So anyway, pretty good graph, and it didn't take us very long to do it. Yeah. Let's see. You're in degrees, not radians. Oh, somebody put something in the way bottom. Was it a person by name Alexa Wood by chance? Okay, all right. See, people do mean stuff. They go into your y equals and they go down to, you know, number 10 where you can't see anything. They put a decimal point there. So then, you know, all of a sudden you go to y equals and you don't see it. You go to graph and it's like, ah, you know. Funny math jokes, huh, Caitlin? Yeah. All right, here we go. We got 2 more. All right, we'll try 2 more difficult ones. We can do it pretty quick. You guys are going to get good at this. What is my vertical shift? And my amplitude? 4. So I'm going to have to go all the way down to -6. Put my axis through -2. What's going to be my maximum value I get to? Yeah, +2. So 2 will be my maximum, -6 will be my minimum. And bounce back and forth between those. I did the first 2. Hey, those were easy. So amplitude is 4, so I go up 4 from -2 to +2. I go down 4 from -2 to -6. Nope. All right, what's the period? 2 pi over pi is 2. Mark it out. But the b value is pi, right? If I take 2 pi and divide it by pi, I get 2. Divide 2 in half, I get 1. Got 1/2. 3 halves. -1/2. -1. 5 halves. Got my period all the way out. Is there a horizontal shift? There sure is. So before I do the horizontal shift, I'll draw a rough sketch. Where's this thing going to start? -6, why? Cosine starts at the max or the min, and because it's negative, it's going to start at the minimum. Now where? Up to -2. Then where? Up to +2. Stupid smartboard. Finish off your points. Come on, come on, come on. Oh, yeah, there it goes. And draw my dashed graph. Okay, my smartboard kind of took a hiatus there. Everybody got that? Now what? What do we have to do now? Horizontal shift, we take pi x minus 1 and set it equal to. How do I solve for that? Add 1, pi x equals 1, divide both sides by pi. X is 1 over pi. Your tick marks for your period, are they in terms of pi or are they decimal? Decimal. So let's make our horizontal shift instead of in terms of pi, let's make it as a decimal. That's approximately 0.3. How does 0.3 compare to your tick marks? Is it more than a tick mark? It's less. Is it more than half a tick mark? Yeah, half a tick mark would be 0.25. So I take all of these points here and I move them over more than half a tick mark. It's not going to be exact. It'll be pretty darn close. Then I can see my horizontal shift. It's all there. This is usually where I get the question of how pretty do our graphs have to be on the test. Some of you have atrocious handwriting. Actually, let me kind of go through it here. None of you have atrocious handwriting. Some of you have below average. But none of you have atrocious handwriting. Some of the other classes have got some bad handwriting. Yep. You guys know who you are. So, if I can't read your work, I don't give you credit for the graphs. Now, here's my question. Instead of drawing graphs like that, anybody do this? Like your graphs get more pointed? Who are you? 1, 2. Oh, wow. The disease is spreading. Okay. I'm pretty lenient with that. I don't tend to take points off for that. But I do have some people that when they draw their graphs, instead of, making, I know it might take some practice. Okay? So instead of drawing that, I will get some that will do this. Okay? I'll get that. And I try to give points, but well, it depends on what kind of mood I'm in. If I'm really hungry, I'm trying to get through the test, I might just say, forget it. Where's my sandwich? Yeah. Okay. I probably won't be too picky with that. I try to understand it, but this is, if you're having that kind of problem, you want to fix that. Okay? Yeah. All right. Here we go. Last problem. Now, last hour we timed ourselves to see how quickly we could draw it, because we said we were really efficient. And I said, how fast would make you feel really proud? And Megan Corton said 10 seconds. And I said, that expectation is just way too high. And she said, well, tough luck. I got high standards. Wow. That's Megan, I guess. She's calling us out. How long do you think we could do this next one in? How fast? 3? 2? Minute and a half. You want to time us? So we got the little phony thing? Okay. All right. So hold on. Wait till we're ready. Okay, I'm gonna do it with you guys. I'm not just gonna fly through on my own. We'll do it together. What? No, we're gonna do it together. Okay. All right. Ready, set, go. Vertical shift is 3. Amplitude 1. So I will go up to 3. Make my line. What is going to be my maximum value? 4. Minimum value? 2. Got that. What's the period? Pi. You take 2 pi and divide it by 2 to get pi. Mark that. Divide it into 4 pieces. What's half of pi over 2? Pi over 4. So I have 1 pi over 4, 2 pi over 4, and 3 pi over 4. Do I have a horizontal shift? Yes. So let's draw the imaginary graph first. Where do I start? The center, where I go up or down from there? Down. There's my graph so far. Let us solve for the horizontal shift. 2x minus pi over 2 is equal to 0. So 2x equals pi over 2. Pi over 2 divided by 2 is pi over 4. Pi over 4 is exactly 1 tick mark. Take all of your spots, move them over 1 tick mark. And done. Oh. Minute 30 is pretty good. I don't know, maybe we're not impressed. I don't know. I think it's impressive we could draw a really good graph in that amount of time. That's the idea. Those are the steps. What do you think? Can you do this? Can you do it well? How about this? Sydney missed all day yesterday, so this was all brand new, wasn't it? With a little practice. Remember, tomorrow, all we're going to practice graphing sine and cosine functions. So by the time we're done with tomorrow, do you think you could be, yeah, I'm ready to ace this puppy? Maybe need a few questions answered first. Okay. All right, your assignment is so your assignment is right up there. If your book gave you a problem like that, y equals 1 plus 3 cosine, where could you move that 1 plus to? Plus 1, yeah. So sometimes people put the vertical shift in front, sometimes people put it in the back. Maybe they put it there for the order. Maybe that's it. Vertical shift, amplitude, period, horizontal shift. I guess that's the order. I never thought about that. Yes, you may.